Hello, my dear friends. Welcome to the course on linear algebra. Now, this is module 1, lecture 1 of this course. Now, in this course, we will see the introduction on linear algebra. Now, the central problem of linear algebra is to solve linear equations. So, here we will be solving the linear equations. The simplest case is when we have equal number of unknowns and equal number of equations. So, let us start with n equals to 2. So, let our set of equations be 2x plus 3y equals to 7 and 3x plus 5y equals to 11. Here we will solve for x and y. Now the method that we will use here is the elimination method. So in this method we will eliminate one of the variable, then get the value of the other variable, and then we will back substitute and get the value of the another variable. So first we will solve for the variable x and then we will get the value of y. So in this way we will get our values of x and y. Now the way that we will do it is using back substitution and elimination. So for elimination, first what we will do is we will multiply this equation by 3 and this equation by 2. So what we will have here is that our first equation will become 6x plus 9y equals to 21, and our second equation will become 6x plus 10y equals to 22. Now you see here that the variable x, the coefficient is same. Now what we can do is we can subtract these two equations. So this will be minus y equals to minus 1. So the value that we get is y equals to 1. Now we got our value for y. Now what we can do is we can back substitute the value of y into one of our equation. So let us take the equation that we had, that is 3x plus 5y equals to 11. The value of y was 1. So we have 3x equals to 11 minus 5. So x will be equals to 6 by 3. So value of x is nothing but 2. So we have the value of x as 2 and the value of y as 1. So this method that we just used here is known as Gaussian elimination. So this method is the Gaussian elimination. The other way that we can solve these equations is using determinants. This determinants part we will see in our upcoming module. Not in this module but some other module. So I hope you are getting what we are doing here. We are just seeing what the basic linear algebra means, and then we are solving the equations here. Now we have an efficient way to get the values of x and to get the values of y. So there is something other than solving the equations. We see the equations, we see these equations as a row system or by a column system. So in linear algebra we have row system and column system. So there are two types of system here, row system and column system. So let me take another part here. Another, let me add a page here. So as I told you, we will have row system and column system. So in linear algebra, we can write our equations in the form of row system or in the form of column system. Now let us take our set of equations, that is, let first equation be x plus y equals to 4 and other equation be x minus y equals to 1. Now previously we solved the equation using Gaussian elimination. Now when we write the equations in this form, this is nothing but the row picture form. So as we are writing in a single rows. Now this will look different in the column system. In column system, what we do is we write this in the form of vectors. So so how do we write this in the form of vectors? What we do is we take this uh, variable x outside. So by outside I mean you take this variable x and then you write this as the coefficient here is 1 and 1. So it will be a vector 1 and 1. Similarly, you take the variable y outside, so this will be plus y. The coefficient will be plus 1 and minus 1. So this is plus 1, this is minus 1. And the right side will be nothing but 4 and 1. So this was of the row picture, this is the column picture. As as our dimensions get bigger, we generally use the column picture because this will be x plus y plus z plus w and this will be a long equation. So generally we prefer the column picture as our dimensions get bigger. Now how can we represent our row picture and column picture? So let us take the equation that is x plus y equals to 4 and x minus y equals to 1. Now to represent this, we can take an xy plane. So consider this as a xy plane. Now what we can do here is we can plot these two lines, that is x plus y equals to 4 and x minus y equals to 1. So our x plus 4 line will go something like this. This will be 4 comma 0 and this will be 0 comma 4. So this is our line x plus y equals to 4. Now our second line will be, it will cross from 1 comma 0 and minus 1 comma 0. So this line will go like this. So they will cross at some point. So this point of intersection will be our solution. So for this case it will cross at 2.5 comma 1.5. So this will be our solution. So we can also get this answer using the Gaussian elimination that we saw earlier. Or you can plot those two lines, the point of intersection will be the answer. Now let us see the interesting approach, that is the column picture. Now this column picture is one of the interesting parts of linear algebra. So what we do here is, this is our, we take this in the form of vectors. So this is our first vector, let us call it u1 v1. This is our second vector, let us call this as u2 v2. Let us, and this is our final vector that we want to reach. So let us call it as uf and vf. So what we do is, we plot this these two vectors, and then we find x and y, so that this x and y, some linear combination of x and y, will take us to the resultant vector, that is 4 comma 1. So let us first see where these vectors lie. So this point 1 comma 1, so let us make a grid here, 1 2 3 4. This will be 1 2 3, and let this be 4. So 1 comma 1 will be something somewhere here. So this is our first vector. So now let us take our second vector, that is 1 comma minus 1. So our minus 1 will be somewhere here. So this is 1, this is minus 1. The final vector that we want to reach is 4 comma 1. So final vector is somewhere here. So this is the point that we want to reach. Now let us go backward, and so that it will be helpful to understand our later cases. Our solution for x and y was 2.5 comma 1.5. So let us see how we can draw this, that we reach this final vector. So what you do here is, this is our first vector 1 comma 1, you multiply it by 2.5, so our vector expands, so it will reach at some this point. So this is the point 2.5 comma 2.5. Now what we do is multiply our second vector by 1.5. So by multiplying by 1.5, we will reach at some location here. Now what you can do is translate this other vector, or you have done this in the earlier mathematics part. What we do is we follow this rule of parallelogram. So this is our a vector, this is our b vector. Now to add these two vectors, either you can move this vector here, so this will be here. So what we see is, this a vector plus b vector gives us our final vector, or you can move this a vector here. So this is our a vector. So what we see is that this linear combination of x and y gives us the final vector, that is our desired vector. So our answer will be x equals to 2.5 and y equals to 1.5. So some value that we multiply to with our first vector, and some value that we multiply with our second vector, so this will give us the final vector. Now as our number of variables increase, the combination of these columns, this becomes much more convenient. So we will need to find some combination that will give us our final vector. So our row picture that we saw earlier was the intersection of this lines. Now suppose we have this as the 4 dimension, that is our first vector is 1 1 1 1 plus 2 2 2 2. Some x variable will be here, some y variable, some z variable, plus some w variable. This will lead to our some final vector. Now to find this linear combination is the whole purpose of our linear algebra course. So what we saw in our first lecture is that, now let us summarize it. Let me first switch off and then again I will switch it on here. Since note, one note. So in our first lecture, what we did is that we solved two equations, first using Gaussian elimination. Then we saw what is row picture, and we saw the column picture. As we progress further in our lectures, this all three will become clear. So in our upcoming lectures, so let me give you a brief what we will see in our upcoming lectures in this module. So basically we will be having four to five modules, and then we will complete our lecture on linear algebra. Uh, but in this module, what we will have is the solving of the 3D equations. Solving 3D equations. This is using Gaussian elimination. So we will see the whole algorithm that is used to solve these 3D equations. The second part that we will see is metric notation. The third part that we will see is the factorization of the matrix, that is given a matrix A, we factorize it into the lower matrix L, the determinant, D matrix D, and the upper triangular matrix U. Then we will see singular cases. And then in our different module, we will see what are vector spaces, what is orthogonality, what do you mean by determinants, and all other things that are useful in the linear algebra. So with this we end this lecture. I hope you all like the lecture, and in our next part we will solve the 3D equations. We will see how to represent 3D equations in the plane form and in the column picture. So I hope to see you in the next lecture. So that is all in this lecture. So thank you for watching.